Games. Make the device fun. I know you guys didn't read your email on the plane. You played something. I want something fun for this device. Doom. I got a demo that somebody cracked together. It kind of works. I want to have lots of games on this device. We've got a great screen now. The screens are like 65,000 colors. The processor is 133 megahertz. What do you need? You've got storage cards to put them on. And people pay money for these things. I don't know why, but they pay lots of money for these games. So what kind of games are out there? Oh, I've seen somebody try to port Colossal Cave. Woohoo. I've seen Trivial Pursuit selling for $50. Guess Doom's running about 400, right? Now, you guys can do cerebral and textual games all day long. That's fine. There's still a need to try to beat Jeopardy. But come on. We need animated graphics. We need 3D games. And I've got a great section of slides on how to write an animated game with some sprite engine code that David Norris has written. And we'll be releasing the source code for that sprite engine immediately after the conference. And I encourage you all to think about what games you could use with it, or write with it. A couple of things we can extend, and we can get quite a few games out there in a hurry. If you saw Doom, we can get at least 2.5D games. I don't know if we can get Unreal. I'm not sure how the up, down, left, and right are going to map to going under and over bridges and stuff. But I'd like to kind of spend a couple minutes talking about player interaction. Most of the games I've seen for this are one player, or one player against a computer. And that's okay. When I'm on the plane, that's all I have. But let's try to make some more fun games. This device is totally mobile. I can go over to your chair, and I should be able to play a game against you. I should be able to, maybe you don't have the game. Maybe we want to play chess, but maybe we want to play together on the same machine. Those two scenarios I don't see enough games on right now. I want to be able to just go someplace and entertain a couple of people with the game. I've seen, actually, the game pack for the palm-sized PC. Chess has a mode like that. That's pretty neat. I tried to get tic-tac-toe running, but, you know, I had to do in a bunch of other samples. I wish I had. But something that you can just nice interactive, draggable pieces. You could go for total photorealistic slot, great, make it look awesome. Put marble textures on there. And finally, multiplayer network game. Maybe not so much for the palm-sized PC, but the handheld PC. We've got proximate wireless networks. You don't have to be nearby each other. You don't have to be plugged in. You guys can actually take advantage of the entire internet. So dream with me a little bit. Work on making the games in a new space than you've seen before. I just wanted to put in context some of the types of games, types of graphical games there are. You have a basic animation program. That doesn't need to do anything fancy with a sprite engine. It doesn't have to do anything fancy at all. You can just put a picture in a static text control and call move window. Boom. You've got a basic app. You can write solitaire in a couple hours like that. Well, if you can draw the cards. Can anybody draw? I can't draw. It looks like ice cream cones. But sprite engine, we'll talk a lot about that in a few minutes. Doom really isn't 3D. If you guys understand how Doom works, you can't go up and down. You can't go underneath any place you've been. It's just a map. It's got an X and a Y, and you move around the map. That's pretty straightforward to do on a device like this as Doom works. The hardest piece, I've seen Doom ports before. The hardest piece was getting the sound planes working, and I'm pretty impressed that they got the sound planes working on this one. And then there's full 3D. This is, I don't know, it's kind of basic. If you think about what it takes to build a game, I can't draw. It's going to look really dumb if I draw it. So I have to find somebody who can draw, and that's probably the hardest part of getting a game together. Game engine, you can buy one, you can write one, you can steal one from the website. I'd like to talk in detail about how, on the palm-sized PC specifically, you can react to user actions. There's some hardware buttons. There's a screen. I'll explain exactly how every piece of that works. Once you've done that, just describe the rules, keep score, and make it really nice with sounds. We've got stereo out on the Casio E100. Stereo out sounds amazing. A lot of people have asked, do I have to use bitmaps? Do I have to use icons? Is that all? No. Just all anybody's talked about for a while. There have been web browsers out for many years. There's been a web browser out since the first Pegasus device. Somebody actually wrote a web browser for palm size, and it's shipping in a couple boxes, and he works at conduits.com. How did he do it? He used the image decompressor library called ImageDecomp, and it cracks open GIFs and JPEGs and PNGs and some other stuff. How do you make a game? You got to draw graphics that look like they rotate. That's the famous rotating meatball. Would have looked a little better had the yellow been always on the left side, like the camera was, or the light source was there. But you can do that pretty straightforward. If you notice, every single piece is 22.5 degrees rotated. It wraps around. If you go from the blast to the front, it comes back up. You can very easily index into a bitmap like this. You just pass in the X position along that array. More complicated versions, maybe you've got 2D. Maybe you've got a ship that rotates and it moves around. And it's got a couple animation frames. You just made it a little more complicated. The second piece there, that's a mask. Guys, maybe you know what masks are, maybe you don't. Mask is simply black and white version of the sprite. Use the mask to figure out what you're going to sprite. You add the, how does that work? You take the bitmap, you only blit the part that's black, and you don't overwrite, and you don't put any ghosts on the resource below. Most fundamentally, you probably don't want to try doing color bitmaps on a gray screen if you're writing a game. So you can find out easily enough. Is device caps HDC bits pixel greater than 4? That'll fail, sure. That'll fail if somebody makes a 16-bit per pixel gray screen. I haven't seen one. I don't think you ever will. That's what an E15 is. It's more than 16 grays. 16 grays is 4 bits per pixel. Whew. Is what? Well, then maybe it doesn't work. Check. What? Well, there are lots of more greater than 5.
No, just increase the number of bits per pixel. That's how you handle many devices. You don't want to?
Maybe you just should test on all the devices out there and check to see if name is equal to Casio E15 or whatever. So that's just a full list. We actually had an interesting question about palette versus RGB, and it looks like on a device that has a palette is completely implemented in the display driver itself, and the palletization code either occurs in the select object or in the bitblit if it is a div section. Thank you, Dave. All right, we talked about basic controls several times in this room. And what I found out the day before I made the slide deck was that there's a bunch of messages called WMCTL color blah. So you can actually change what the common controls display, how they display. So as you see, this is an app I'm going to go through in a minute. But on the left is what it looked like before. That looks like an app that's got lots of threads in it and processes and whatever. Second one is if I just did erase background. And the third one is when I used color control static. The way that particular one worked, and I think they're almost all similar, you set the text color, you set the background color because you are given the HDC, and you return the brush object to paint the background in. So I haven't seen a lot of this done on our devices yet. I've seen a lot of good color apps written, but I haven't seen a lot of this done. I hope to see more of this in the future. All right, I'm confused. Why did that slide sneak in there? All right, we're on the next talk now. So I guess in some book, some famous book named maybe Petzold's book, he used the term the mighty bitblit. So we thought about this, and we decided you should never use stretchblit, you should never use draw text, and you probably shouldn't ever use text out. And text out's okay for debugging. You can do everything in bitblit, everything. In fact, I was in a discussion with an earlier operating system that Microsoft was trying to build. They were putting it in a very small form factor device, very little RAM, very little ROM. And I remember sitting in a meeting, and they actually said, we support line draw, but it's too big to put diagonal line code in. It's 1K. We're not going to support Bresenham. If you want a diagonal line, you can blit it yourself. Okay, well, we don't need 1K anymore, so we put it back in. But you can do it with BitBlit. One of the variants of BitBlit may be PatBlit blackness, PatBlit whiteness to draw your line. Might be another thing to think about. BitBlit takes some sort of raster ops code. They're complicated, they're orthogonal, they're complete. Some of them don't make any sense. But the first three are the ones you use almost all the time. I think Dave will talk about exactly when he used all those. He's got a sample about that. Let me just cover image decomp for a minute. Image decompression, as I said before, lets you read all the bitmap files, types from the web, and it returns a DIB section. DIB section, if you're not familiar with that, stands for Device Independent Bitmap. And a DIB section has the bitmap points in it as well as a palette in the header. So this is useful for a web browser, and it's also useful for a paint application. In fact, the Pocket Paint application that ships in the Plus Pack uses the uses the DIB section. How do you use image decomp anyway? It seems like the header files and lib files aren't around. I've found a copy of them on some website somewhere, and when we release the source code for this, it'll be available on the website with our sample code. Simply put, there's a structure called decompress image info, and an API, decompress image indirect, and I guess you pass the structure to the API. And then what do you do with it? You get callbacks. It's meant to work on an internet provider, so it's going to deal with stream data and image data and image process. Wow, horrible slide. Can't read a thing. Okay. DW buffer max. The tip here is pass 4K or bigger buffers. Tend to get things from the web. 4K is a good number. Bit depth. Well, you think maybe I call get device caps. Figure out, oh, it's a 5-bit gray screen or something. You have a choice. If you pass in 24-bit per pixel, then the conversion from 24 to 5 is going to happen at getObject, or at select object time. If you ask for 5 bits, then it's going to happen in image decomp. Might be a trade-off. You can figure it out yourself. If it's better for your picture, pass in 24 bits. The LParam is what structure is passed when you get callbacks. It's how you can communicate between your two callbacks. Scaling's kind of funny. I guess I would have implemented it a different way myself. This actually says if I've got a picture that's 100% of the screen, or 100% of the picture size is 640 by 480, but I want to show it at 620 by 250, well, then I'm going to have to make sure that one of them fits in there and figure out, oh, the zoom factor is like 23%. So you have to do a little math there, because max width and max height only cut it off. Okay, so say you've got a standard GIF, and standard GIF, the upper left-hand pixel says this color is transparent. So you can make a completely transparent picture where the background's transparent and it's got a little donut in it. But how do you make a perfectly square picture with a round hole in the middle? You pass in a color to see our transparent override, and that'll put a hole in the middle of your graphic. I hope you can read this, because this is all you need to do to get the image data. You will be called, when you ask image decomp to put a picture in, you'll be asked for each block. And you can call read file, or you can call internet read file, and you can put it in. This is in the slide deck, so I'm not going to linger on it. Oh, I want to say one thing, though. When you're done, you return 0. No bytes. This slide's a little more interesting. It introduces a structure called the inline image info, and it sets the HBM, the iOrg height, and the iOrg width members. Those are actually available, and they're just coming in from the iImage render. I didn't explain that very well. Hopefully the slide explains it better when you look at it. Sorry. There's actually 2 demos available that fully describe this. and how to use this control. In fact, this website is where all the code samples that any of talks that I've been a part of are going to be. And there are some samples up there already. The samples we actually discussed in detail in this session will be put up after the conference. Any questions about image decomp at all at this point before I move on? Yes? Yes, what? Yes, it's fully supported. I don't know. Does include it? And now it does. I think maybe you just have to copy it from the HPC 3.0 SDK back. It's always been. It's supported on all. Yes, it's been supported since palm size PC 1.0. You can figure it out backwards because every time you've seen the mobile channels application showing a picture from the web, it's using that control. Yes. Would it be on AutoPC? Does anybody in the audience know? I don't personally know. I don't think so. Something you might be silly enough to try copying the files down to the AutoPC, except it might have a different processor. Anything else, question-wise? Okay. To be honest, I've never really used image decomp, but I got some slides from somebody, so that was kind of choppy. What I have done is I've reacted to user actions a lot. And I wrote key test exe to explain it. First of all, the mouse. Everybody knows you get L button down messages, and actually on the HPC you get right button down messages. But how does it actually work on the device? What actually messages do you get? How frequently do you get them? I'll explain that in a second. If you look carefully at how the mouse works, you'll only get mouse move messages if the mouse is over your window. You can override that by setting and releasing capture. On a palm-sized PC, we have ink, rich ink. It's available. You don't have to resort to text input. And this sample of a high score actually explains the detail in code how to use a rich ink control to capture things and make an interesting high score list. I don't ever want to have to figure out some up-down control combination to get to the letter Q and type my name in a game. Just ask me. I'll write it. Sometimes I write God. Can't put a smiley face in if you have to scribble it in. Okay, I'm going to switch back to the demo here. Let's actually explain and show exactly what happens when you press every button on the device. So I'm going to press the up control on the front of an E100. I get a key down and a key up. If I press and hold the button, I get several key downs. And then when I release, I get a key up. So if your app is interested on the key repeat rate, you can actually just wait for key down events to come. If you're more interested in is it currently down, call get async key state and pass in VK up. It'll tell you if it's up or down. VK right works the same way. Press and hold. I get several of them. Down, you guessed it. Left, you guessed it. Okay, so the action, or the rocker switch, how does that work? Rocker switch, that sends down. Okay, it works exactly like down. Up. Okay, anybody here know how the action key works? I'll tell you, it returns a VK return sometime. Anybody ever used it? Anybody know what it does? You'll never guess what it does until you write an app like this. Whoa, what in the hell? Sends you a VK F23, followed by a bunch of zeros, followed by an up F23, and then a VK return. So if your app only cares when the action button's released, you can pull for VK return. If you care, VK23 goes down, that's when your button's down. You can actually then deal with firing in like rapid fire, repeat fire kind of scenarios on the action button. I bet you guys can guess how escape works, though. Oh, you can't quite see. F23, and F24. That's the only difference. Okay, now there's this extra thing. On an E100, there's these other buttons. There's these app launch buttons. And it'd be really neat to be able to go left and right and fire. If you've ever used this device, you know that you go left and right and try to fire, you get calendar running. Oh, yeah, I got their menu app. Thanks. So I wrote a sneaky little routine called grab buttons. Little background. You get a hotkey. Why does calendar run? Calendar runs because they went to the buttons control panel. They typed in, they selected calendar for button 1, and button 1 actually got written somewhere in the registry. And when calendar launched, calendar asked, called the shell API sh get app key association. They passed in calendar exe, and it returned vk app launch 14. Then they called register hotkey, and now they got their message. Problem is, how do I get it back? How do I steal it from calendar? I figured out how, and I'll show you the code in a second. But if I grab all the hotkeys, now if I press and hold the button 1, I get hotkey app launch 2 followed by key up. Based on this example, it looks exactly like the shell stole key down. Fine, but I get a hotkey for key down. So now my loop is hotkey, key up. That works for all the app launch buttons. Actually, if you don't have the app handy, but you have the slide deck handy, I've summarized it right here. Okay, so I already mentioned sh get app key association and register hotkey. If you're writing an application, use these. There's several reasons to use this in general. Calendar actually does two interesting things with the launch key. If you press it once, it brings up calendar. If you press and hold it, you get a new appointment. All it did was it started a timer on hot button, checked it when the timer fired, it called get app key association, and said, is it still down? Yes. Start a new appointment. So that's something you should do in your app. If you do it in your app, you have to respond to the SPI app button change flag to the WM win INI change. That's sent out whenever anybody uses the button control panel. You can change it to be from calendar to contacts or to your own app. Just put the same code in both those two places. When you're done, call unregister hotkey. That's the right way to do it. Problem is, how do you get it away from calendar? Well, if you look here, unregister hotkey takes an hwind and an ID. The ID is a number from 0 to 0xBFFF. I don't know how fast 133 megahertz is, but I guarantee you my for loop from 0 to BXXX is going to take a little too long. So, dug around a little bit, asked the buttons control panel, hey, how do you do it? I cannot support this, ever. I cannot support this, ever. I cannot support this, ever. But it works. And this is how it works. You say, I want to steal VK app launch 1 with mod win. And mod win is just how everything's done on the palm size. Now, you have to promise me if you're going to use it because it works, that you play fair. Give them back. Remember, you had to handle the SPI app button change. When your app's done, call unregister func, unregister them all from yourself, and just send this message. Broadcast it. Everybody gets it back. So how does it actually work? I didn't bury this code anywhere, did I? Details? Again, this function will be available for everybody. It's a little bit obscure. I called through a function pointer because I wanted it to work on palm size and on HPC for the sh get app key association. But I just call register hotkey. In fact, now that I think about it, it only does work on the palm size, but I wanted the app to compile on HPC. So I can show you how I did that in a second. Unregister hotkey And that's the unregistered. That's how to play nice. How to not play nice. Right there. You want to register mod win VK app launch 1, just steal it. I commented out sh set app key wind association because it does half of the job. If calendar is not running, then it'll take calendar's button as long as I've got focus on the front. So that's another thing to be aware of. Okay, I mentioned earlier, high score should be fun. High score should just let me scribble in whatever I want to scribble in. Got an InkX control, I should be able to use it. How does it actually work? Let me show you what the code does first. I've written the code in such a way that you could actually use it in your own app. I'll give you the source code for using it. And so I just had to enter a new high score. So let's just type in a really large number. What's my name? And there it is. I guess I must have let some people play with it. I've got some scribbles in there. So I wanted to point out a couple of things on how that actually worked. So I've also written a function that will make the rich ink, or make the InkX control not have a command bar, not have a scroll bar, and actually pop up to be in ink mode. Because I've had a lot of questions about how you do that. I can find my code. Oh, good. So like every good little hacker, I used Spy. And I asked Spy, what are the windows in the InkX control? And it said, well, the first one's a rich ink window. The second one's a scroll bar, or the command bar, and the third one's a scroll bar. And I said, gosh, I don't want the scroll bar, and I don't want the command bar. So I made them go away. And then I made the window for the rich ink almost the size of, or slightly bigger than, the ink control. So the last comment on the bottom, how do you set the ink mode? I don't have any idea. There's a couple messages that I don't know how they work. But I do know that if the SIP's down, it comes up in ink mode. And if the SIP's up, it comes up in text mode. So I wanted ink. I just made sure the SIP was down before I called this. So we need one other piece of information. Once you get the ink note, how do you write it out to a file? How do you read it from a file? They did a very good job when they wrote their API. There's one message, set data, there's one message, get data, and it returns the entire data blob. And you can write it to a file, and you can read it from a file. When you're actually getting the data, you can call get data length, and you can allocate the right buffer to send in. So you can read and write ink controls really easily. You can fill them up, and you can, if you want to, you can even open them up in rich ink if you put the right extension on the bottom. So I encourage you to make winning your app fun, make winning your game fun by putting the high scores in ink. So I've summarized what I've done here. If you guys want to refer to it when you're not in the conference anymore. You can also pass a clear all message, and that'll blank it out. Okay, I've got a game. I got one of my friends who can draw. They've got some graphics. I've got some game engine written. It's no fun without sounds. Doom without sounds is not fun at all. But what do you have available? You have PCM formats of 8, 11, 16, and 22 kilohertz. I'd probably recommend like 11 or 16. I think most of all devices ever made support those. They weren't all required since the beginning of time. You have 3 choices for playing the sound: play sound, play sound, and wave out. Play sound, you just pass the name of the file. Boom. If you've got a PCM file, you call play sound, get sound. On a stereo device, I guess you get stereo sound. Wave out, Wave-out's for the people that want to be hackers and want to actually write their own mixer or do something complicated. I don't really recommend you use it right now. But if you want to write a mixer, that'd be great. If you look up on the website, somebody named Jimmy has written a really cool mixer. And I don't know what his licensing agreements are or what you want to write your own mixer. But basically, the theory on a mixer is make all your files the same, the simplest mixer in the world. Make them all 11 kilohertz. Make sure that when you add two sounds together, you don't get an overflow problem. So just clip them, and then add them together. When do you add them together? Well, you can use wave out, and you can do it in 1K blocks. Send 1K to the wave out driver, queue up a couple of sounds. When the user presses the fire button, add the fire sound into the background that's looping. That's a mixer. How do you get stereo sound? I asked that to myself, and I guess the Casio just works. But you have to be careful. If you're going to play with wave out, you've got to make sure that you restore stereo sound as opposed to mono sound. I've got a bug against me right now in the Power Toys. Mute actually will turn it to mono, and I've got to go home and fix that. So I'll know the answer to that question as soon as I get home. So how much time is left? I want to give Dave as much time as I can on the Sprite engine, so I think I'm going to try to blitz through the CE cards DLL. But I would like to say that this is written on top of PEG cards DLL. PEG cards DLL is really boring. It's a resource-only DLL. It only contains card backs. Can't do anything to them. CEcards.dll was written by the unsupported software company. It's going to be available on conduits.com CE/dev. And it will do everything you basically need to do to write a card game except do your logic. It'll deal cards. It'll draw a card at a specific location. It'll drag and drop a card. It'll drag and drop a pile of cards. And it will let you get all the information out of the card that you desire. All the information out of the card. So it's red, it's hearts, it's a queen. It's got one bool and 3 ints. You might want to not show queens or make the queen of spades worth 13 points. You can add a custom hard card back, and it's even usable from VB, because it is. All right. At this point, I would like to turn the stage over to David Norris, who is my boss in real life.
Oh, thank God. Someone else is here with a tie. I walk around this building all day. I'm the only one with a tie. My name is David Norris. I've been at Microsoft for about 15 years, and although I've done millions of different things there, I'm probably most known for a stupid game I wrote over a weekend called Taipei. I don't know how that happened. So I want to talk about sprites. I put together a little sprite engine for you guys. It's free. You can get it from the website that we previously mentioned. My talk is at various technical levels. I don't want to get too deep because I want to try to cover as much as I can. A sprite is typically implemented in hardware, but because all of our devices don't have sprite hardware on them, we've done it in software for you. Okay, so you would do all of the work that you would do as if you had sprite hardware and use this engine. A sprite is an irregularly shaped, animated graphic. It can move around the screen, do whatever. It can be whatever you want it to be. It can be a tumbling rock. It can be a character blinking his eyes or moving his hands. Flaming bowling ball. That's from Donkey Kong. Remember the monkey? He throws the barrels down. They look like flaming bowling balls. I don't know what those are. So there are two kinds of animation. A sprite-based engine is a cast-based animation because you have a fixed or scrolling background. You can think of it as a canvas or a painting on which little things move about, as opposed to a frame-based animation like Doom, where the entire frame changes from scene to scene. It's like a movie or a flip book. Okay? That second type of animation is a little more difficult to do. You saw our Doom demo. What are we getting, Tim? About 5-6 frames per second, which is not quite enough for really good animation. You need at least 10 frames per second, preferably more. My sprite engine, I think we're getting 15 to 20 with 4 or 5 different sprites on it, but it's not optimized, and I'll talk about that later too. So why do we want a sprite engine? Well, first of all, we want to draw as little as we can, right? We only want to draw the parts of the screen that need to be updated, all right? So we do all of that off screen. And we do it off screen for actually two reasons. One of which is we don't want to update it several times, because then you'll get this flashing, you'll get a black piece, and then another sprite, and then another black piece. You do it all off screen, you do your update region, and then you paint it all at once with BitBlit, okay? So you reduce the flicker. The second reason you want to do it off screen is because off-screen blits are always faster than screen blits, okay? And speed is key here. Okay, now we're going to jump back and forth here. Let me pull up. Okay, go to engine.cpp there. Oh, we're there? Okay. This is fundamentally how Sprite Engine's going to work. You start by creating an off-screen bitmap, a memory-based bitmap that corresponds to the region that you want to update. And you use create compatible bitmap. Now, there are three ways to create a bitmap, right? You can do create bitmap, you can do create dib section, and you can do create compatible bitmap. And I recommend you use create compatible bitmap because it might be able to use video memory, and that's faster. So use create compatible bitmap to create your off-screen bitmaps. The first thing you do is you blit your background using source copy. All right? And here I have diagonal lines that represent the background. That's the canvas or the painting part that I'm talking about. Okay? And then for each sprite in the region that you need to update, you first take your mask. Now, you remember earlier Tim had a slide that had the rotating meatball. That's really an asteroid, but it sort of looks like a meatball. And the second graphic was the mask. Well, here's where the mask comes into play. All you want to do is draw the part of the sprite, and it's irregularly shaped. So you want the background, even though it's square, to show up in that area. So what we do is that we black out the area where the sprite is. In this case, we have a little red heart we want to show, though. We do that with source and we do that because the white part of the mask is where the background will show up, and the black part of the mask, when you and it, of course, goes to blackness. Okay, so what we've created is a little cutout where our sprite's going to go. And then their third step is we do a source paint. That's where we take the sprite itself. That would be the first bitmap where the area that's not the sprite is black. Okay, and we do a source paint. So we get red where we want to, and the black part is where we get the background. And then the last thing we do is we blit that whole thing to the screen. Now, this is all done for you in this code I'm going to give you, but I want to give you an understanding of basically how the Sprite engine works, so you know why you have to do all of these bitmaps. Let's look at the code real quick. What are we at? This one? Okay. Here we are. Okay. So first we're going to create the bitmap. You see I'm doing a create compatible bitmap with the size of the redraw rectangle that we want. And we select our temporary bitmap into the temporary DC right here. This is the off-screen DC, correct. Okay. And here's some interesting bit of code. This is where we're going to draw the background. Okay. Now you may not have a background. Maybe it's black. And in that case we do a patblit, because patblit is awesomely fast. Use patblit whenever you can. But if we have a background, then we draw it. And here you can see the source copy right here. Okay? Once we've got that done, then we want to put our mask in. So after we check to see if the sprite needs to be displayed, we source and the mask, and then we paint the sprite over it. Now, this particular sprite engine will deal with wrapping. So if you have a sprite that goes off of one edge and appears on the other, right? This is a meteors game. And so this next bit of code does wrap. And I'm not going to go into that because it's a hairy mess. Finally, we blit it on the screen, and we just do a source copy right there. Okay, let's go back. And I want to talk about something a little more technical here. There are different ways to do this. Okay? One of the obvious you might ask is, why not use direct draw, or why not use DirectX? If we have DirectX questions at the end, I'm going to defer them to Mike Daly, who's down in front. Wave your hand, Mike. He's the dev guru for DirectX. Well, we don't have DirectX on the palm-sized PC or the handheld PC. The availability of that is completely up to the whim of the OEM. All right? So you don't know if you're going to get DirectX or not on any platform that you're writing for. And so my recommendation to you is, wherever possible, use the lowest common denominator that works for you. Now, BitBlit is like as low as you can possibly get. BitBlit is always going to be there. Okay? So I recommend you use BitBlit if you can. This operation here, where we're doing the mask and putting the sprite on the screen, there are other functions to do that. One is called transparent image. Another one is called mask blit. You're saying, well, why can't I use those? Well, you can. I'm not going to go into the functions themselves, but it may or may not be faster. Okay? If the device supports transparent blit in the hardware, then it will be faster. If it doesn't, then it will be much slower. Okay? And you can find that out. If you really want to make your game as fast as possible on all platforms, then what you're going to want to do is do a get device caps. I'm not sure what the index is, but to see whether the hardware supports transparent blit. And if it does, then you want to do mask blit or transparent image. And if it doesn't, then you want to use the code that I have. You want to do 2 blits, okay, these second 2 blits. Now, that was kind of hairy, but the 2 blits will always work. Okay, and for this particular application, you'll see it's actually fast enough. And so if it's fast enough, why bother? Okay, let's take a look at what we got. Tim, go ahead and pull that out. You want me to play that? Or are you like totally helpless with that?
Oh, I managed to play it a couple times.
All right, good luck. Oh, can we bring the sound up on? Oh, wait, bring it down, down. We gotta plug it in.
Yeah, that's the best part.
Okay, you can bring it back up. Yeah. No, the other way. There you go. Oh, too much. Perfect. Okay. We're still not hearing anything, though. There it is. Fire something at that thing. There you go. I don't hear any sound either. It's on mine, but yeah, it's down there. Why don't you go ahead and get it while I talk about what's going on here. The engine that you're looking at supports, first of all, animation. The code that to move the sprites around is all self-contained. All you have to do is tell the sprite engine, here's the bitmap for the sprite, here's the XY, the DX, the DY, go. And the sprite engine will take care of everything else for you. It just runs. Okay. While Tim's doing that, I'll bring this back up. It supports collision detection at a certain level. Okay. In that if the bounding rectangles of 2 sprites overlap, they collide, and you get a notification message and says, what do you want to do? This sprite collided with something. One of the things you might want to do with this particular game, if you're going to write your own, if you want a finer granularity of collision detection, if you have for example, a large L shape, the corner of that's going to be up here, and if a round meteor comes close to that, it will collide even though it doesn't look like it's colliding. So in that case, you'll want to do a blit of the inverted, let me get this right, you want to do a blit of the inverted masks of the 2 sprites and see if there are any bits that are left on that will give you a pixel level collision detection. Now it turns out for this game, you probably don't need it. I've tried it, and this, for the rectangular collision detection is good enough. And then lastly, it does the screen wrapping and collision detection with a screen wrap for you if you want that. Okay? Okay, so let's go back to see if Tim's got this figured out. There you go. No, don't shoot that way. Ah! Okay, fire. You blew it.
I blew it.
Run away. Okay. It's amazing what one call to play sound will do for a game. And that's something the Palm will never do. Okay. All right, we're done with that now. What can you do with this engine? Basically, it's, as I say, the sample code's free. You can get it off the web. Do whatever you party on with it. Do whatever you want to with it. To write a game with this engine, I swear, it took us a day, a little more than a day, to put this game together. It was that easy. The hardest part really was the bitmap of the meatball. You know, getting the meatball to look just right. It's really hard. But the hardest part of the code was just the getting the updates for the physics of the rocket. You know, how the rocket's going to slow down and move a particular way when you apply thrust to it. And even that wasn't too hard. Huh? There was a bug? The bug is still in there. I don't want to explain that bug. Yeah, well, okay. The bug in this engine, I'm not going to fix it, is that in real life, ignoring relativistic effects, right? As long as you apply a thrust in a given direction, you will continue to accelerate in that direction. Well, with a sprite engine, that's going to look stupid. You'll eventually, the rocket is going to go so fast that the update's going to be dumb looking. It's just going to appear all over the place. So you want to limit the speed. I'll bring it up. What the heck? Is that it? Yeah. Yeah, bring up meteors.cpp, and we'll actually go ahead and look at some of that code, I think.
There you go.
Okay. Ignore some of that. Here's lots of fun. This is basically, we're doing all the pre-calculation of the directions ahead of time. You always want to do that, and I'm going to talk a little more about that with bit blitting in a minute. But so we'll ignore all of this foolishness. So the sprite engine is going to have a couple of callbacks. One of them is update. This is what to do when an explosion updates. Basically, the sprite engine handles the explosion for you. Right now it's asking you, what do you want to do when it's reached the end of the animation? Well, we want to kill it. That's it. That's all the code you have to write to do that. The meteor, basically there's built-in code in the sprite engine that says, if you have simple linear movement, these callbacks, these methods are going to work for you. Just call them. Same with the torpedo. That could have been the same function, I guess. If you collide with a meteor, you need to kill it because the meteor dies. You make your explosion noise. There's play sound. Real easy. Then you create this explosion sprite. You add it to the engine. Let's see. Oh, this is an interesting bit. If I pull up my win main and you look at my basic win proc, you won't find me processing any key messages at all. I basically do get async key state for everything, and I just check for the side buttons and the scroll and the exit button. Those are the only ones I needed. And I just want to know if they're down at each frame of the animation, so I just call this function. It's real easy. The hardest part was figuring out, when I press this button, what do I get? Is that a VK escape? What is that? That's where Tim's app comes in really handy, the key app. You just press it. Oh, it's a VK F23. How obvious, Here's where we update the velocity, and here's where we're getting to the bug, this line right here. So you can see we limit the acceleration, or we limit the speed in any given direction. Well, you can't really do that because if you continuously apply thrust to the rocket in, say, a 20-degree angle, it will max out the thrust in both the x and the y axes. And so instead of going at the direction the rocket's pointed, it sort of skews it and goes this direction. It looks kind of weird. Yeah, it always goes 45 degrees, basically. So we could fix that with a little better tables, but I'm not going to bother with it. Okay. So, to create your game using this sprite engine, what do you need to do? Well, the hardest part, as I said, you got to create those bitmaps and the masks. It's not hard. I can do it. It looks like a meatball, but you make the masks. You can do all of that in Paint. Okay. You add the sprites to the engine. You need to handle the collisions. What do you do when two things run into each other? You may want to take this and have an asteroid break into 4 parts. You basically just destroy one sprite. You create 4 more. No big deal. You handle the movement updates. And then you have to have the rudimentary gameplay. You have to have the UI, start a new game. Do you want sounds or not? We'll put something simple here, a simple dialogue, but you're going to want something a little better than that. So, different ways to improve this. Some of these I recommend, some I don't. First of all, a side scroller you might want to do. A good example of a side scroller sprite game would be Golden Axe, where you have a painting that's extremely wide and the viewport sort of scrolls back and forth along that. All right, it's still fixed, but you can look at anywhere along that. You start at the beginning and you end down here. So you might want to add that for a game like that. You may want to have sprites that overlap. This engine doesn't support that, but that doesn't mean it's hard. Basically, with a meteors game or asteroids, anything runs into anything else, it blows up. But you may want to have sprites that sit on top of one another. That's not too hard. You just need to add something to the sprite object to do the Z ordering and then paint it properly. This third one I really don't recommend. I know our good friend Jimmy down in Thailand has done this. He's come up with some code to directly access the frame buffer, and then you can go party on the bits. If you want to do that, you're certainly welcome to do that, but it probably won't be supported. BitBlit always will be, and you saw the game. It works great. There's really no reason to revert to that, so I wouldn't recommend you do it.
Well, the other reason is different layout on the screen button. Interleave frame pattern.
Okay. I've already talked about the finer collision detection. If your game warrants that, for example, you have a large sprite, 64 by 64, that's very irregularly shaped, you may want some finer collision detection. Now, there are some other ways to improve this. If I go back, no, I won't go back. Basically, you want to try to do all of the operations that you can before you start the engine. All right? If the only thing you have to do is a BitBlit, then that's what you want to do. All right? So what I haven't done here in the sample code, and what you would want to do in a real application, is when you create a sprite, you create the memory display context for it, you select your bitmap into it, you realize the palette into it, and you get it all ready to do a BitBlit. Okay? Now, I don't do that now. Could you bring up engine.cpp, and we'll take a look at take a look at that. Let's see. Here we are. So you'll notice that this is missing something. Anybody know what it is? No? There's no palette code here. And there should be. And this talk isn't long enough to go into a really good discussion of palettes, but we're doing this on an E100, which has a 16-bit display surface, and so it doesn't actually have a palette. It's a virtualized 24-bit display context, so everything works. It's no big deal. But on other devices, you may have 8 bits per pixel, and then the device driver is going to just provide a palette, and then you have to do the palette. You have to realize the palette of the bitmap into the display context. So you would want to do that there. But you want to do it before you start the animation. So when you create the sprite, you want to create the display context for that individual sprite. So each sprite would have its own display context. You would want to select the bitmap of the sprite into that display context, as well as a mask into its own display context. All right, so that when you are ready at this stage on each frame to update your display, all you need to do is BitBlit, just BitBlit, because these functions are going to take time. All right, and you don't know how much. And if you have to do a color conversion here, it's going to be dog slow, and you don't want to do that. All right, so you might want to do that in the engine too. I've been actually considering doing it in the sample code before we release it. Okay, this is a book that I really strongly recommend you get. It's 95, so it's a little old, but it's by Nigel Thompson. He's a friend of mine way back in the multimedia group. Animation Techniques in Win32. He goes into a lot of detail about sprites and div sections. He talks about stretch div bits, which is not in Windows CE yet, so you have to sort of talk around that. But you get a really good understanding of sprites and palettes and so forth from this book, so that's a good one to get. Now, for those of you that is that one in here? This book isn't in here either. If you're an old hack at writing Windows games and you know all about Windows GDI and all of that, I recommend you pick up this book. This one's available out here, Inside Windows CE. Frank and Sharpe, they talk about their design decisions when they came up with, some people call it GUIZ, some people call it GUIZ, the graphical system in Windows CE, and why it's different than Windows, and why Windows CE devices don't have a palette, why there's no palette manager, for example. And if you just read a few of the chapters in here before you start writing your game, you're going to avoid a lot of pitfalls. Why doesn't my palette work properly, right? You'd find out if you read that first. So I do recommend you read that. Here's some more, Here's some more reading material that I recommend. The top two are pretty obvious ones. If you're into computer graphics at all, Foley and Van Dam is the Bible of computer graphics. It's like 1,200 pages. Get it. It's like, you got to have that. If you're interviewing for a computer graphics programmer and he hasn't heard of this book, don't hire him, okay? It's like you go to SIGGRAPH and everybody knows what this is, okay? The last two are more oriented toward the desktop, but you're going to learn a lot about fast graphics from those two books. Okay, we're open for questions. Yeah? Oh, wait.
I just wanted to say that Ask the Experts has started right now. So if I actually request you take your questions with us down to Ask the Experts and just ask them there. Sorry.
Okay, we're going to go down there? All right, we'll see you there.